Hey guys, this is Jimmy from Planning C's Tutoring. In this video, we're going to be talking about fractions operations, so operations on fractions, like addition, subtraction, multiplication, and division, with fractions, of course. Now, don't forget to use my referral code Jimmy120 to get 10% off on your next tutoring package. So whenever we work around with fractions, there are certain rules that we want to follow that's slightly different from just generic integers or general integers or any kind of number, like whole numbers or anything. In general, whenever we add or subtract numbers, you would just be doing for example 2 plus 2 equals 4, or maybe 5 divided by 2 equals 2.5, which is equal to 5 over 2. Well, whenever you're using different operations just based off of fractions, well, any rational number can always be represented with a fraction. So this technically applies to every single whole number, every single integer that you've already worked with, but you can apply this to a lot more numbers. Like, for example, let's say that you wanted to do what is 1/3 plus 1/9. Let's say that's the question. Well, you can't necessarily just add up whatever the numerator says and what the denominator says, because that's not going to get you exactly what 1/3 and 1/9 are going to get you. And the reason behind that is because the denominator gets, as the denominator gets bigger and bigger, that means there are more pieces to be sliced out of, which means that the size of each piece gets smaller and smaller as the denominator gets smaller, or as the denominator gets larger. So the actual value decreases as the denominator increases, or if the numerator decreases. Well, in this problem, for example, the numerator increased by 1, but the denominator increased by 3. So it's going to be a huge size decrease. So that's not exactly what you would be doing. Instead, let's actually start by focusing on addition and subtraction. So whenever you're adding or subtracting any kind of fractions, you always want to just add the numerators. So there are actually two sets of rules. The first rule is if you already have a common denominator. So let's say that you have 1/4 plus 3/4. Well, if you already have a common denominator, the common denominator just means that the denominator of both fractions have to be equivalent. If you already have a common denominator, then all you're doing is just going to be adding up whatever the numerator says. So this is going to become 1 plus 3, and then the denominator of this huge fraction is going to be just 4, the same denominator, which gets me 4 over 4, or in other words, 1, if I simplify this. I can do this with slightly different fractions, maybe 2/7 plus 3/7. Same exact stuff happens, and I would be getting, well, since I have a common denominator is going to be 7. 2 plus 3 is going to be just 5/7. Same thing applies with subtraction. If I wanted to do, let's say, 4/13 minus 2/13, well, this is just going to be 2/13, because common denominator is 13. 4 minus 2 is 2. You can also apply this to negative fractions or negative numbers and stuff. So let's say you were doing -3 over 17 plus 10 over 17. Well, in this case, you're just adding a -3/17, which is the equivalent of subtraction, and therefore you're going to be getting just 7 out of 17. Alright, now part 2 of actually working with addition and subtraction is when you don't have the same denominator. And an example is just the one that we just worked on earlier today in the session. it was 1/3 plus 1/9. When you notice a problem like this, the first thing that you want to do is you want to find the least common. You want to change the fraction so that it has a common denominator. And the way that you can do this is by multiplying either one or maybe both fractions as necessary so that they have a common denominator. So here I can multiply by 3 on the denominator so that I can get a 9. If I multiply both of these 3's together, I would be getting a 9. The reason as to why I multiply by 3 on the numerator as well is because I want to make sure I'm not changing the entire equation or anything. Whatever I did to begin with, I don't want to change the fact that I'm doing 1/3 plus 1/9. Had I only done 1/3 times 1/3 or something of that nature, what happens is we're going to be changing the entire equation as a whole. Whenever I do 3 divided by 3, what happens is 3 divided by 3 is the same thing as just 1. And 1 times any number is always going to be itself, so I didn't really change it, technically speaking. So this just becomes 3/9 plus 1/9. And you can kind of check me on this by just simplifying 3 9s. If it simplifies back to being 1/3, then that means that 3 9s and 1/3 are effectively the same exact thing. Now this simplifies down to being, well, now it's just adding up two common fractions based off of a common denominator. So this just becomes 4 9s. Now let's say that you have a number like 1/2 plus 1/3. Same kind of material applies. You would start off with trying to figure out what a common denominator is. So here, I can make both of these denominators into a 6 if I multiply the second one by a 2/2 and the first one by a 3/3. This gives me 3/6 plus 2/6, which gets me 5/6. Alright, let's now look at multiplication and then let's go on to division. So multiplication is actually going to be very, very similar. Multiplication is going to be very similar to how you would be working out division. It's just division has an extra step in it. Let's say that you're working with the numbers 2/5 times 7/8. In a problem like this, whenever you're multiplying two fractions, all that happens is you're multiplying whatever the numerator says and whatever the denominator says. So in this problem, we would be getting 2 times 7, which gets me 14, 5 times 8, which gets me 40. This right here can simplify down to being just 7/20. That would be my response here. Let's try that again. Maybe let's use 2/3 and 4/5. Well, in a problem like this, same exact thing. 4 times 2 gets me 8. 5 times 3 gets me 15. So this leaves me with 8 out of 15. This cannot be simplified any further, so I'm leaving it as is. Alright, now let's get into division. Division may appear to be the trickiest, but the tricks are all the materials more or less very, very similar to what we've already done. So when you divide two fractions, when we talk about division, it's very, very similar to how we did multiplication, but instead there's going to be a slight variation. So where we have 2/5 divided by, let's say, 1/2, the first step that you want to do is just multiply by what we call the reciprocal. The reciprocal is going to be the flipped off version of whatever this side right here is. whatever the second value is, whatever the second fraction it is, that whatever fraction it is that you're dividing by. So this here becomes 2/5 times 2/1. Now this is just multiplication, and you get 4 out of 5. Another one that you can try is maybe 2/3. Actually, let's do 5/6 divided by 2/3. Well, this is the same thing as 5/6 times 3/2, which gets me 15/12. And this actually I can simplify to being 5/4. So in general, we can figure out like a rule for like the generic case for any of these problems. For addition and subtraction, if they have a common denominator, I would just leave it as a/b. If I'm representing this with like a variable or something, I can say a/b plus b, or c/b is going to get me a plus c/b. Let's just select that and choose a different color, not to confuse anyone. Alright. Next one we would have is if they are different terms. Well, if they are different denominators, the easiest approach to any of these kind of problems would just be, let's say that they have a/b plus a c/d value. Whenever I have different letters, that just means it's going to be different values. Well, this is going to always be the same thing as b. That's supposed to be d/d times a/b plus a/a times c/b. That's supposed to be b/b. b/b times c/d. And now you can multiply, since d times b is the same thing as b times d, that means they have the same exact denominator, which means that you can now just regularly add them together or subtract them together. Multiplication, if you have a/b times b/or c/d, this is always equal to a times c divided by b times d. Then just simplify. Finally, division, a/b divided by c/d is always equal to a times d over c, b times c. You can also re-represent any division sign as a fraction. So let's say you have like a divided by b. This is always going to be represented as, this can also be represented as a ratio, or a divided by b. Alright, that kind of covers up this video. I hope you guys have all learned something new about addition, subtraction, multiplication, division on fractions, and I'll see you guys next week.